It's iPM with Eddie Mair and Jennifer Tracy.
Hello and welcome to iPM, the programme that starts with its listeners.
And this week...
The Temptations?
No, we're talking nuclear. Have we spoken about liquid fluoride thorium reactors?
Were they in the Hobbit film you saw?
No, you're thinking of Thorin, leader of the dwarves, who hates elves and is trying to reclaim the lonely mountain from Smaug the dragon.
Let's not get drawn into a conversation about dwarves and elves again. That's what got us thrown out the wine bar. So why are we talking about liquid fluoride thorium reactors?
Because one of our listeners thinks it could be the answer to Britain's energy problems.
Well, this was the week when the man who runs the energy regulator Ofgem, Alistair Buchanan, made a speech about our future energy needs, which may have given you the heebie-jeebies.
Yes, he says falls in the UK's power production capacity are likely to lead to more energy imports and price rises. Longer-term solutions to the UK's energy needs, such as new nuclear power stations, have yet to be given the final go-ahead by the government.
There is no new nuclear.
There was also a file on 4 this week, which you can still catch on the radio player. It reported on the UK's civilian plutonium stockpile, the largest in the world, which has been growing for 50 years.
So we've now spent quite a lot of time scratching our heads and wondering what to do with it, especially in relation to its potential harm as a bomb-making material.
All of which worries listener Colin Megson, who believes there is a nuclear solution that has for too long been ignored.
Colin is a former mechanical engineer who worked for a time on nuclear submarines, but is now using his retirement to blog about new technologies.
I suppose it started off with somebody sticking a paper in front of me when I was 11-year-old, and I ended up passing the 11 plus exam. I hadn't a clue what it was. Ended up at grammar school, scraped my way through 7 GCEs, couldn't wait to leave, no sense of A-levels and university, that was all for the posh kids. So I went with my dad to the nearest pit, got myself a job as an apprentice pit fitter, and spent 9 years with the old NCB. And I think I was heading into a snowstorm, 5:30 in the morning, on my way to Kellingley Colliery. And I thought, I'm not doing this for the rest of my life, so I started getting myself a bit of education. And within the space of 12 months, I'd gone from being a pit fitter to being with Rolls-Royce and Associates in the research and development department, and they were a consortium of firms manufacturing the nuclear reactors for the submarines. I retired at 70 after about 54 years in manufacturing engineering. Looked around for something to do, so I had a couple of years with an open university course in science, and then probably 2.5 years ago, I tripped over liquid fluoride thorium reactors.
All right, stop. I'm going to stop you there. Liquid fluoride thorium reactors. Come on, what are they?
Well, I would say this is a new form of technology, but that's not really the truth, because these things were operating back in 1965, I think it was, when a gentleman called Alvin Weinberg, who'd spent time on the Manhattan Project, proposed the use of a nuclear reactor that had a liquid form of fuel, as opposed to the reactors that were really taking the front of the stage. These were the pressurized water reactors in the submarines, etc., and they used solid fuel rods.
And what was so special about using liquid?
Well, with the liquid, of course, that's melted down. So you would never see the phenomenon that we hear so much about when things go wrong with our pressurized water reactors, because they melt down, as we know at Fukushima and 3 Mile Island.
And this has been around for, well, decades.
It has, but it lost funding because the pressurized water reactors, which were being used in the submarines and in some power plants, one of the byproducts is plutonium, and the whole emphasis of the nuclear industry way back in those days was the production of plutonium for nuclear and thermonuclear weapons. And in the days of the Cold War, of course, that's all that really mattered.
So using liquid just fell out of fashion, if you like. I mean, this is obviously...
It lost funding, yes.
Right. I'm suddenly thinking of Betamax versus VHS. VHS took off because more people were using it, and that was the kind of adopted standard. Is it a bit like that?
A bit like that, but I suppose the analogy these days would be the pressurised water reactors are in fact the VHS, and the lifter is the MP3. Goes in your top pocket.
Tell me how much better you believe it is than the existing systems.
Well, it can be configured as a breeder reactor, and
What's that?
well, a breeder reactor is where you take a material which is termed a fertile nuclear material, and you can turn it into fissile material. Now, the fissile material is the ones that split in two. When we say splitting the atom, they split in two, and they give out all the nuclear power according to the, altogether now, Einstein's formula, E equals mc squared. That's it, yep. And my sort of catchphrase on the little blog that I run is that breeder reactors, on the back of a fag packet, the arithmetic shows that they can power the world and give an energy-rich future to every single individual on the planet, even when there are 9 or 10 billion of us, and it can do it for the whole of time, all of eternity, as far as the planet Earth is concerned.
Colin, that's quite a claim.
That can be substantiated on paper.
Or a fag packet.
Or a fag packet. Because basically the thorium fuels, and it can also be uranium fuel, these are inexhaustible at the level we will ever use them in breeder reactors to provide all the energy we'll ever need.
And less likely, to put it bluntly, to go bang.
Yes, that's certainly the case, because the fluoride salts which contain the atomic fuels, these are inert when it comes in contact with water or air. So you could breach one of these reactor vessels in a lifter, and the salts would literally just glug, glug, glug down the side of the reactor vessel and solidify and do no harm to anything.
And the waste, the scale of waste would be what?
The scale of waste is minuscule. It burns up all of the, well, I say the ill-informed and duplicitous call nuclear waste. It isn't nuclear waste, it's the UK's most precious energy resource. There's enough energy in our nuclear waste, inverted commas, to power the UK for 500 years.
What about if the government and energy companies were to say, OK, let's do it? What would the cost be, what would the timescale be in comparison to the nuclear that we understand?
Well, the nuclear we understand comprises of a reactor vessel and 3 or 4 steam generators, and these vessels are 60 or 70 foot long, 20 foot diameter. The bodies are made from single pieces of steel, and the wall thickness is about 9 inches. And you can imagine not too many people supply those. In fact, it's just one company in Japan who can supply these vessels. And of course, we haven't got the machining capacity in the UK to manufacture them. So there's a lot of the new nuclear that we're about to get. There's a lot of that work is going to be purely imported. The lifters operate at atmospheric pressure, so they don't need wall thicknesses of 9 inch. They only need wall thicknesses of 1/2 inch.
Wow.
And so we have the manufacturing capacity, and we've certainly got the nuclear expertise in this country to be able to manufacture lifters in their entirety. The licensing, of course, is the big problem, but in total, with goodwill and a bit of foresight from the politicians, you might be able to force the licensing through in 5 years and get the first prototype, first of a kind, up and running in another 5 years.
What is the downside? Because you haven't told me about a downside.
Well, the downside is that the reactor that ran very successfully at Oak Ridge National Laboratory, it ran for over 4 years, and it ran a few thousand hours at full power, But it was only, I may be wrong here, but it's something like 5 megawatt, which runs about 5,000 one-bar electric fires.
Right.
So the scaling up will need a fair amount of development. So that's going to be the biggest hold-up.
Is anybody working on this?
There's a company in the States in discussions with the military to see if they can organise a small modular version to power military bases.
Colin, I know you've got children and grandchildren. How much do you worry about their energy supply?
I worry terrifically, and this has really been the driving force behind me putting so much time and effort into lifters. I think that, one generation down the line we'll see problems where we only see the ripples now, and that's energy security. We only need the Russians to turn the tap off a little bit and the Middle East countries to start playing silly devils, and we'll be in trouble.
Do you think this technology will be adopted in your lifetime?
No, unfortunately, I don't. Mainly because
how long have you got?
I haven't got very long left, I don't think.
Oh, come on.
But no, having said that, I actually switched horses in midstream to the GE Hitachi Prism reactor, which is now being considered at Sellafield for the disposal of our plutonium stockpile. And that's another form of reactor which can be configured as a breeder. But the reason I basically switched horses was because I can see that happening in my lifetime, and I really do want to get a glimpse of a brighter future for my grandchildren.
Listener Colin Megson.